Let's derive an expression for electric field due to an electric dipole on its equatorial plane. So first of all, let me draw here an electric dipole. Let's say this is our plus q charge which is placed over here, and there is minus q over here. Separation between plus q and minus q is 2a as usual. Okay, why we are taking here 2a instead of a or r or l? Simply because when you take the distance from the midpoint, okay, the distance we can, instead of getting unusual a by 2, we will get a and a. Okay. So this is the gap between plus q and minus q, and this is a perfect electric dipole. Now if this is an electric dipole, we have to find its field on equatorial plane. Equatorial plane means, in a simple language, equatorial plane means a line along the perpendicular bisector of this dipole. Perpendicular means if you draw a point which is perpendicular to this dipole, and it is splitting this dipole into two equal halves, which means this is A and this is also A. Okay, such a line anywhere on this line. So let's say this point P over here, this is at a distance of R. So this point P is our equatorial plane. Now due to a positive charge plus Q, the field will be radially outward. So we can draw here electric field due to the positive charge is radially outward. Why we made it in this particular direction and not in any random direction? Because this is the line joining the point charge and this point P. Let's draw the field, electric field due to the negative charge. So we know electric field due to a negative charge is radially inward towards the charge. So let me draw it here. This is the line joining the charge and the point P. So the field will be in this direction. Let's write here, this is our EQ, Q, and this is our E minus Q. Clear? Now if this is R and this is A, what will be, and since it's a perpendicular bisector, let me repeat again, this is angle theta here is 90 degree. So we can use Pythagoras theorem. Okay, let's call it as A point, let's call it as O point, and let's call it as B point. So in triangle AOP, this side will be hypotenuse, which will be square of perpendicular plus base. So R square plus A square. And even PB, if you find the length of PB, it will be root under R square plus A square. Now what is important in this derivation is you should know the diagram properly. If you know the diagram, then things becomes very easy. Great. So AP and PB both are equal. And if you look at this complete triangle APB, the side AP is equals to PB, then can we say that if I assume this angle theta, this will be equal to this theta? Angle opposite to the equal sides are equal, correct? So we got our this angle theta, and this is also angle theta, whatever angle it is. Okay, not necessary you have a particular angle, it can be any angle, but it should be equal. Why? Because AP is equals to PB. Great. Let's go back to our electric field. So electric field at point P due to the first charge is EQ, and due to the second charge is E minus Q. Where will be the resultant? Now here we will apply class 11th concept. The resultant of any two vectors which are inclined like this will be in this direction. So this will be our E net electric field, correct? So let me draw a separate diagram just to make it easy. Okay, so let's say that this is our EQ here. Let's draw it here so that things will be quite clear. EQ, and here it is E minus Q. And the resultant of both is in this direction over here. This is our E net. E net means the total. Now let's draw a convention, simply x-axis and y-axis, so that things becomes quite easy. This is our x-axis and this is y-axis. As you can see that y-axis is along the perpendicular bisector over here in the diagram, and x is along the electric field E net. Great. Okay. If this is angle theta over here, can we make this as angle theta? Yes, because they are corresponding angles. E net is parallel to the line joining the two charges. Okay. And if this is angle theta over here, this angle will be alternate angle. So this will be also theta. So let's make it here E theta here, and this is theta over here. Correct. I hope the diagram is clear till now. Okay. Now let's write the value of EQ and E minus Q. So first of all, let me remind you, electric field of any charge is given by K. K is what? 1 by 4 pi epsilon naught, or let's make it more specific and write it 1 by 4 pi epsilon naught. Charge, any charge Q upon the point at which you are finding R square, where R is the separation between the point and where the charge is kept. So let's use this relation of electric field and find electric field due to plus q and minus q. So electric field due to plus q is 1 by 4 pi epsilon naught small q upon, what's the separation between the point P and A? AP square. And if you write the value of AP, this will become q upon 4 pi epsilon naught. AP is what? Root will go and you will get r square plus a square. Now, let's figure out the electric field due to the negative charge. It will be 1 by 4 pi epsilon naught. Be very careful, you will not take the negative sign. Why? Because we have already considered it in the direction. If this charge, the second charge will not be negative, your arrow would be outward, right? So you have already considered the negative sign there. So that's why PB square. And what is PB? Again same. So q upon 4 pi epsilon naught r square plus a square once again. So one thing is clear. The directions are like this as per the diagram over here given. But the magnitude wise both the electric fields are equal. Great. How to figure out now the resultant or E net? One way is by using resultant formula, okay, and putting here the angle between EQ and E minus Q. So if you don't know the resultant formula, R is equals to root under A square plus B square plus 2AB cos theta, okay. Now this method is not given in your textbook, but let's solve it this way first so that we will understand the concept, and then we will go back to our the method which is given to us in the textbook, okay. So if R is equals to A square plus B square plus 2AB cos 2 theta in this case, okay, 2AB cos theta. We will now substitute. A is what? A is electric field EQ. So this is EQ. And even B is also E minus Q, same as EQ. So let's write it as EQ only. Doesn't make any difference because magnitude wise we have found here both are equal. Plus 2 times EQ into EQ, and what's the angle between them? Cos 2 theta, right? Angle is theta and theta, so cos 2 theta. The angle between the two vectors we have to find, not between the resultant and field. Between first vector and second vector, this complete angle is theta, 2 theta. So let's write it here. It will be, now take E square Q common, 1 plus 2 times cos 2 theta, correct? We can also take this E square out. It will be EQ root under 2 plus 2. Let's take 2 common out again. So here 1 plus 1 2 and 2 cos 1 plus cos 2 theta. Now 1 plus cos 2 theta is nothing but this is for maths people. So if you are not having maths, NEET, or if you are from bio, you can simply skip this part for next few minutes, okay? So that we will go directly to the method which is given in the textbook. So 2 into 1 plus cos 2 theta is 2 cos square theta. And 2 into 2, we can take out 1, 2 and into cos theta. So you got this resultant. Now you can put it and this will be a E net, okay. But we will see that what method they have used in the textbook. The same method will also result in this thing. What is EQ into 2 cos theta? Let's see now how. Okay. So here, let's go back to our vectors from class 11th. If you are given with any vector EQ, which is making any angle theta, okay, with the x-axis, it can have 2 components. First component will be in this direction. We will call it as EQ, cos of angle theta. Another component will be in this direction, EQ, sin theta, if you remember from 11th standard, correct? And E minus Q will also have 2 components. Here it will be EQ, E minus Q, sin theta, and there it will be EQ, in this direction only, E minus Q, cos theta, correct? What we can see here is EQ sin theta and E minus Q sin theta. One is going up, one is going down, and both have same values. We can see on the left hand side of the screen. If they have both same values, one is up and one is down, then the vectors will cancel out each other. And hence, EQ sin theta and EQ sin theta cancels out. But only electric field is contributed by, so E net is only contributed by whom? It is contributed by EQ cos theta plus E minus Q cos theta. I hope this is clear. Yes. So EQ and E minus Q, they are same. So let's make it as 2 times EQ cos theta. If you find this easy, you can use this convention. Very simple. Now let's substitute the value of EQ. So 2 times EQ is nothing but Q upon 4 pi epsilon naught r square plus a square into cos theta. Let's go a little up and see our diagram that will help us to know about cos theta. Okay. So here, if you look at this triangle PAO, in triangle PAO, look at this triangle. Roughly, let me draw this triangle. Cos of angle theta is nothing but base upon hypotenuse, right? Now, what is base? Base is, sir, AO, which is A, and hypotenuse is nothing but r square plus a square. Let's go back and substitute our values. So, this will be 2q upon 4 pi epsilon naught r square plus a square, and cos of angle theta is a upon root under r square plus a square. And if you multiply this, okay, now you can imagine that this root is nothing but power half here, and this is power 1. So powers add up when you multiply. So this will give you 2aq upon 4 pi epsilon naught r square plus a square whole power 1 plus half 3 by 2. This is electric field, net electric field due to the dipole. But if you go back to the diagram, you can see that the electric field is pointing in this direction. Okay. And if you want to find the dipole moment will be from negative to positive. Always. Dipole moment for an electric field is from negative charge to positive charge. And what's the value of dipole moment? So let me write it for you. Dipole moment is given by P, this is a vector, and that is equals to 2 times A into Q. 2A is the dipole length and Q is the charge. So let me put here in terms of dipole moment. So this will be 2AQ, we will make it as minus P. Why minus, sir? Because the direction of electric field, as I have shown you, is opposite to the direction of dipole moment. So a negative sign arises. R square plus A square whole power 3 by 2. This is our net electric field on a equatorial plane due to an electric dipole. Now there is a simple case. What is the case? That if, let me write here, if R is much greater than A. Okay. Just imagine that R is 100 and A is 2 or 0.1. Okay. So if I take just a hypothetical value, I am taking R as 0.1 and R as A as 0.1 and R I am taking 100. What is the square of R? So square of R will be 10,000, right? And sir, A square will be what? 0.01. So if you take a smaller number, okay, square of a smaller number becomes much more smaller, while square of a larger number becomes much more larger, right? So that's why R square will be much greater than A square. And in that case, can we say that R square plus A square is nearly equal to R square? Why? 10,000 plus 0.01 is nearly 10,000 only, right? Okay. In that case, this expression will take the form minus P upon 4 pi epsilon naught R square plus A square, R square whole power 3 by 2. 2 cancels, we left with minus P upon 4 pi epsilon naught R cube. So what we conclude here is the net electric field due to a dipole is inversely proportional to R cube, while for a single charge it is R square. I hope this is clear.